Hello students, welcome back to Vastiversity. You are going to be doing the product and quotient rules for differentiation. So let's go ahead and start with a product rule, right? So the product rule, the notation DDX format is as following, right? So if f and g are both differentiable, then the derivative of f and g is going to be f times derivative of g plus g times derivative of f, right? So in the prime notation, it would look like this, right? So we have the derivative of f times g, which is equal to f times g prime plus g times f prime, right? This is very important. This is not equal to, so this is very important, f of g, so f of g prime, so times is not equal to f prime times g prime. This is crucial. It's not equal to it. Okay, so now let's go ahead and essentially we will be proving it, right? And the way we're gonna prove it is we will do that the following way. So if we say that we have capital F, right, of essentially capital F, and what we're gonna do is the increments that is increasing, so we're gonna have that it's u times, okay? So essentially when we want to do the f of x plus delta x, right? We're going to do this delta x. It's going to be essentially the same thing as u plus delta u times v plus delta v. All right. So essentially, we are able to do that, right? It's not illegal operation. Here we're essentially approximating around the first order here, right? And that's actually, for us, it's perfectly enough, right? Perfectly enough to be able to say that that's a statement, right? So that's we can prove it by use. We can also prove it visually by using the rectangle, right? The rectangle. So essentially, this is one of the geometry proofs of this statement, right? So our function is essentially the area, right? So if we take a look, what's the area? The area is going to be the multiplication of this side times this side of this rectangle, right? And essentially, we have that, in this case, delta u is equal to f of x plus delta x minus f of x, right? And delta v is going to be g of x plus delta x minus g of x, right? So essentially, the new area or value is good. So we are allowed to do that changes of the delta terms. Okay, so that means if we do so, we're gonna have that the limit as h, well, in this case I'm going to use delta x actually, as delta x approaches 0. Delta x is actually h, but here it will make more sense. So we have delta f of delta x, but delta f is actually going to be this part minus this part. So we're going to have limit as delta x approaches 0 of u plus delta u times plus delta v minus, right, minus u times v all over delta x. Okay, so in this case here we have to open up the parentheses and simplify. So we're going to have limit as x approaches 0, okay, of u times v plus v times delta u plus u times delta v, so change in v, plus delta u times v minus u times v. Okay, so our classic scenario, we're gonna cancel out the first term and the last term. And now, the most important part is to actually divide each term separately by delta x, right? So break it up into the fractions. So we're gonna have limit of x up 0 of v times delta u over delta x plus limit of x up 0 of u times delta v over delta x plus limit of x up 0 of delta u delta v over delta x. Okay, so here are a few important things to note. So this term, right, by definition, this is delta u over delta x, this is the derivative, u prime. Okay, this delta v over delta x, right, this is the definition of v prime. Right, here this is also definition of v prime, but u, delta u is approaches 0. Right, this is the whole thing about delta u. Delta u is a part of delta x, and it's going to be approaching 0, so this whole term is going to approach 0. Okay, so that means we're going to be left over with v times u prime plus u times v prime, right? And plus 0, because this term becomes 0. So essentially, right, we've proved that if we have u times v prime, it's going to be equal to u prime times v plus u times v prime. Right, perfect. So, right, this is the product rule, right? So an example. Right, let's go ahead and take a look at an example. So if we have f of x to be equal to x times e of x, right? So the most important part when we are taking derivative, right? And we have to always double check that we are dealing with product rule, we're dealing with multiple functions, not a single function, that we have to do something that haven't seen before, essentially, right? Or haven't seen, but we haven't have any kind of formulas for, right? We know that we have a general formula that we have to apply. So in this case, we know that we have two functions. So our essentially u, right, is going to be x, and our v is going to be e to the x. Okay, so essentially f of x prime, so f prime of x is equal to dx of x times e to the x, which is equal to, so first x times dx of e to the x, okay, plus e to the x times dx of x, right? And remember from the previous lesson, we know that e to the x is e to the x, and derivative of just x is 1. So we're going to have x e to the x plus e to the x. That's going to be right. And well, we are also allowed to do double derivatives, right? But first, let's simplify this one. This one can be written as e to the x, x plus 1. Right, so now let's go ahead and find the second derivative. Right, so we're going to have dx of x plus 1 times e to the x, like this. Right, so that's going to be x plus 1 times e to the x. Well, let's not skip it, times derivative. X plus e to the x times the derivative of x plus 1. Right, so again, by using the rules, we're going to get x plus 1 e to the x plus x, which will be equal to x plus 2 x. Okay, and so essentially, for if we continue, right? If we continue, we can probably notice a pattern, right? X triple prime is going to be x plus 3, right? E to the x. Then f fourth derivative, I use it as normal numerals, so we're going to have of x is going to be x plus 4. You can prove that. So that means f of n, right, of x is equal to x plus n e to the x. Very nice formula here. Yeah. Right. Now the interesting thing is, well, we can also have a quotient rule, right? How about if we have two functions divided by each other, right? Can we take a derivative of that? Yes, we can, right? And in our case, the quotient rule is written like this. So there are multiple ways that we can prove it, right? We can use essentially the same approach, and we can use, a lot of limit rules and everything to actually prove it. Right? You can take a look at the book on page 186, and you will be able to see the proof that the book provides. But we're going to do it different. We're going to do it easier, right? Because we already proved, right? We proved, and the proof was valid for the product rule. So now we're going to just use that. So let's go ahead and prove it. So we have the following. So, and of course, before I prove it, let me actually give it you into the prime notation. Right, so into the prime notation, this is how it looks like. Okay, so f over g. So, okay, that means, well, our goal is going to be the following. So f is equal to, right, the capital F is equal to u over v. And the most important part here is that v is not equal to 0. Right, same likewise here. G is not equal to 0. Right, very important. There is no note on it, but we're going to add the note. So, but well, rather than trying to find an indigenous way of how to actually prove it, how to actually do it, and do it through fractions, instead of that, let's go ahead and use the product rule. Right? So how can we rewrite u? So since we know that v is not equal to 0, u will be actually equal to u over v times v. Okay, so now let's go ahead and take the derivative. Right? So I'm going to go ahead and take the derivative of it. So dx. Okay. So we will have the following. So we know u prime is equal to u over v times v prime. So v prime. Okay, so we have u prime is equal to, so using the product rule, we're going to have u over v prime times v plus u over v times v prime. Okay, so now let's go ahead and multiply both sides by v. Right, we're going to multiply both sides by v. So we're going to have u prime v is equal to u over v prime times v squared plus u v prime. Okay, let's go ahead and subtract u v prime from both sides. So this and this cancel out. So we have u prime v minus uv prime equal to u over v prime times v squared. And now the last step is to divide both sides by v squared. Right, since we know that it's not equal to 0, so v squared cancels out. So what do we get? We get that u over v prime is equal to u prime v minus u v prime over v squared. All right, and that is exactly the same equation right here as given by definition. So okay, perfect. So we could prove it, right? And that was a much easier proof because we already proved the product rule. Okay, now well, let's go ahead and some examples, right? Some examples on that. So let's go ahead and do. So example, so we have a function, right? A function f of x is equal to e to the x over 1 plus x squared. Okay, so in our case, we understand that this is u over v, and u here is e to the x, e here is 1 plus x squared. Okay, so d dx of e to the x over 1 plus x squared, right, by quotient rule, we're going to have e to the x prime times 1 plus x squared minus e to the x times 1 plus x squared prime all over 1 plus x squared squared. Okay, so that's going to be equal to e to the x times 1 plus x squared minus 2x e to the x. Okay, over 1 plus x squared. Squared. Okay, so that's equal to, so if we bring that in, so we're going to have e to the x times 1 minus 2x plus x squared over 1 plus x squared squared. That's equal to e to the x times 1 minus x squared over 1 plus x squared squared. All right, perfect. And so that's the simplest form of it. All right, let's go ahead and do another problem. So another example. So we have y is equal to x squared plus x minus 2 over x cubed plus 6. Okay, so again, our u is x squared plus x minus 2. Our v is x cubed plus 6. So then y prime is going to be equal to x squared plus x minus 2 prime times x cubed plus 6 minus x squared plus x minus 2 times x cubed plus 6 prime all over x cubed plus 6 squared. Okay, so that's equal to, let's see, so 2x plus 1 times x cubed plus 6 minus x squared plus x minus 2 times 3x squared over x cubed plus 6 squared. So let's think through simplification here. So if we open up the parentheses, we will get 2x to the 4 plus x cubed plus 12x plus 6 minus 3x to the 4 plus 3x cubed 6 squared all over x cubed plus 6 squared. So if we simplify it, we're going to get, let's see, negative x to the 4 minus 2x cubed plus 6x squared plus 12x plus 6 all over x cubed squared. All right, perfect. So now let's go ahead and make a small table of differentiation. So for the last few lessons, we learned already quite a few formulas. So let's go ahead and make it as a single table here. All right. So this is going to be our table of differentiation, right? As we did last time, right? Some of the problems from last time, some of the power rule, e to the x, addition, subtraction, constant, and today we also added to it the product rule and the quotient rule. So next time we will go over trigonometric functions and the chain rule. All right. Thank you guys and see you all next time.